You ever stop and wonder what connects your social media feed, the GPS on your phone, and, well, the entire internet? You might be surprised to learn it all comes down to a hidden mathematical language. And it all started with an impossible puzzle from almost 300 years ago. So yeah, let's dive right in.
Okay, so let's set the scene. We're going back to 1736, to this really cool city in Prussia called Königsberg. It was built around a river, right? And it had this unique layout with two big islands in the middle. The islands were connected to the mainland and to each other by a total of 7 bridges.
And the people living there came up with a kind of brain teaser, a challenge. It sounds simple enough. Can you take a walk through the city, cross every single one of those 7 bridges, but, and here's the catch, cross each bridge only once? For years, people were stumped. I mean, they tried everything, starting from different places, taking all sorts of weird routes, but nobody could pull it off. It seems so simple, but it was like this perfect little mathematical
Right, so this puzzle was just a local legend for a while. That is, until it got to the desk of a genius mathematician named Leonhard Euler. And Euler, well, he was the guy who changed everything. He took one look at it and realized everyone was tackling the problem from completely the wrong angle.
See, Euler's genius was that he could just cut through all the noise. He said forget the streets, forget the buildings, forget what the city even looks like. He stripped it all away. He realized this wasn't a puzzle about geography at all. It was a puzzle about connections. It was about the network.
So what did he do? He invented a whole new way of looking at it, a new kind of math, which we now call graph theory. It's so elegant. He said, let's turn each piece of land into a simple dot. We'll call that a vertex. And each bridge, that's just a line connecting the dots. An edge. That's it. Just dots and lines. And just like that, a whole new field of mathematics was born. How cool is that?
And boom, there it is. That's the aha moment. The complicated, messy map of the city suddenly becomes this super clean, simple drawing, a graph. The question is now totally different. Can you draw this shape without lifting your pen off the paper and without going over the same line twice? And Euler proved, mathematically, that the answer was no, it's impossible. He figured out that to do it, a graph can only have 2 odd dots at most, dots with an odd number of lines coming out of them. But the Königsberg graph, it had 4. So puzzle solved. It was literally impossible from the start.
But here's the thing. Euler's solution wasn't really about bridges at all. It turned out to be this universal key for understanding connections of any kind. And that simple, powerful idea, just dots and lines, is the hidden architecture behind, well, almost everything in our modern digital lives. Think about it. Every single time you hop on social media, you are one dot, a vertex, in a massive graph with billions of other people, all connected by friendship edges. The whole World Wide Web, that's just a giant graph where web pages are the dots and the links between them are the lines. And your GPS, that's nothing more than a program finding the shortest path for you in a gigantic graph where intersections are the dots and roads are the lines. It's everywhere.
And it's not just tech, not by a long shot. This way of thinking is everywhere. Chemists use it to model molecules, treating atoms as dots and bonds as lines, which helps them design new drugs. Neuroscientists are trying to map the 86 billion neurons in our brains as a graph to figure out how consciousness even works. And biologists? They use graphs to model entire ecosystems, tracking animal migrations or even predicting how a disease might spread. It's absolutely fundamental.
Okay, but let's be real. The world is messy, right? It's way more complex than just, yep, they're connected, or nope, they're not. So to make these graph models even more powerful, to make them truly reflect reality, we've got to add a few more rules to the game.
So for example, think about Facebook. If you're friends with someone, they're friends with you. It's a two-way street, right? In graph theory, we call that an undirected edge. But what about Twitter or Instagram? You can follow someone, but they don't have to follow you back. That connection only goes one way. That's a directed edge, and we usually draw it with a little arrow. This one simple difference lets us model all sorts of relationships way more accurately.
And we can take it even further. We can add numbers to the lines, to the edges. We call these weights. And this is the secret sauce behind how Google Maps or Waze actually works. The graph it uses doesn't just have roads and intersections. Each road, each edge has a weight. That could be the distance, the speed limit, or, the real-time traffic. That's what lets the algorithm find not just any path to get you there, but the absolute best path, right now.
So you see, we start with this incredibly simple idea, dots and lines, and we just add these extra layers of information, and suddenly graph theory becomes this incredibly essential tool. With it, we can start to tackle some of the most mind-bendingly complex problems in the world.
I'm talking about huge challenges. Like, how do you find the single most efficient route for a delivery truck that has to visit hundreds of different cities? Or how do you manage a global supply chain with millions of moving parts? How do you schedule every single flight at a huge airport so nothing crashes? These are all colossal puzzles, right? But at their heart, they're all graph theory problems.
It's funny, it took more than 100 years after Euler for someone to even give this idea a name. It was another mathematician, J.J. Sylvester, who finally called it a graph. He understood that what he was looking at was a universal language, a way to describe the deep-down relationships between things, the stuff that stays the same even when everything on the surface changes.
So, next time your phone gives you directions, or a social network suggests a new friend, I want you to remember those 7 bridges in Königsberg. It's just such a powerful reminder that sometimes the biggest breakthroughs come from looking at a really complicated world and finding the simple, elegant pattern hidden just beneath the surface. The world really is just a giant network of connections, and now you know how to see it.